What is the primary objective of today's renewed race to the moon? At its core, it's the push to establish a lasting human presence beyond Earth. Reaching the moon first in the coming years is only one part of the challenge. The ability to build and maintain a functional lunar base will be just as important in determining the true outcome of this competition. SpaceX is drawing major attention with its bold plan to build a moon base using its fully reusable giant rocket Starship. For many people, the US is seen as the winner of the first moon race because American astronauts landed on the lunar surface multiple times during the 20th century. That achievement was historic, and it reshaped humanity's understanding of what we could accomplish. However, it doesn't mean that today's race is any less important. In fact, the stakes are far greater now than they were decades ago. This new effort is not only about planting a flag, it's about establishing a lasting presence, learning to live there, and using the moon as the foundation for a new era of exploration. This return is the moment when humanity will attempt to create the first foothold of a civilization beyond Earth. A permanent base on the moon could become an outpost that enables deeper journeys into the solar system. It could support scientific research, resource extraction, and even the construction of spacecraft that would be too large or too difficult to build on Earth. For this reason, landing astronauts again is only the first step. After people arrive, bases will need to be built. These bases must be reliable, safe, and capable of expanding over time. That leads to the obvious question, how will these bases actually be built? Many people imagine what their components will be constructed on Earth. Many people imagine that their components will be constructed on Earth, similar to the way space station modules are built, and then shipped to the moon to be assembled. Others imagine sending heavy construction equipment that can shape lunar resources into usable materials. Both ideas are valid, and both have been discussed for decades. However, each comes with major challenges. Transporting large structures from Earth is expensive and slow. Bringing construction machinery to the moon is equally difficult. And using local materials requires a level of infrastructure that does not exist yet. Because of these hurdles, SpaceX has proposed a very different idea. Instead of building modules on Earth or constructing them from scratch on the lunar surface, they could convert the lander itself into a moon base. Starship, the enormous vehicle designed for the Artemis program, could serve as both the transport system and the foundation of the first outpost. This concept sounds bold and imaginative, but it immediately raises the question of how such a tall and massive vehicle could become a functional lunar habitat. For long-term use, Starship would need to be positioned horizontally so that living and working inside the structure becomes comfortable and practical. A horizontal layout would also make it easier to integrate with the terrain and connect future expansions. In conventional thinking, tipping a structure as large as Starship would require a giant crane or a massive support frame, both of which would be extremely difficult to deliver to the moon. Transporting such equipment would defeat the purpose of simplifying construction, therefore another solution is needed. One of the most reasonable approaches is similar to concepts proposed by Astrostrom. In this scenario, once Starship lands, rovers would clear and level the surrounding terrain. Any small hills would be broken down, and low areas will be filled to create a stable work area. After this preparation, a large air cushion would be deployed beside Starship. This cushion would be wider than the vehicle and designed to support its weight. Once the cushion is confirmed to be stable, Starship's landing legs would be adjusted. Since the legs are designed to fold, two of them could retract slowly, allowing the vehicle to lean toward the cushion. The cushion would compress gently, supporting Starship's gradual descent without causing sudden impacts that could damage the structure or its internal systems. After the vehicle is resting on the cushion, the air would be released gradually, lowering the ship onto the lunar surface. The cushion would remain as a liner or be removed. When Starship is in position, rovers would begin covering it with a protective layer made from lunar regolith. This layer would serve as radiation shielding, improve thermal stability, and protect the base from micrometeorites. At the same time, the interior would be reconfigured. Since Starship's habitat is originally oriented vertically, SpaceX could design its internal structure to be easily rearranged for horizontal living. This is one possible vision of how a SpaceX moon base could take shape. Do you think this approach is better than other moon base plans? Respond with yes or no in the comment section down below. To me, this approach offers a wide range of advantages that go far beyond convenience. The first and most immediate benefit is the dramatic reduction in time and effort required to establish a functioning lunar outpost. Traditional methods would require NASA to transport numerous base components, specialized modules, and construction machinery from Earth to the Moon. Each of those systems is heavy, complex, and expensive to launch. Building a base in this way would demand multiple missions with large payloads, and every additional flight adds cost, risk, and delays. By contrast, if Starship itself becomes the moon base, NASA and SpaceX eliminate the need to transport an entire catalog of base hardware. Instead, they only need to focus on a compact and efficient inflatable air cushion system that can be stored throughout the journey. The main engineering challenge would be perfecting the controlled process of lowering the lander from vertical to horizontal. Once this conversion is complete, the entire systems can be rearranged, and the outpost would be ready for habitation. Speed matters in this new era of lunar exploration. The sooner a stable base is established, the sooner scientific research, resource extraction, and long-term development can begin. In a competitive environment, being the first to build a sustainable presence could shape the future of lunar activity for decades. That alone gives this strategy enormous strategic value. Another major benefit is the full use of Starship's potential. A lander of this scale, equipped with advanced life support, power systems, communication equipment, and enormous internal volume, offers far more capability than a small dedicated lander. If Starship were used only as a landing vehicle and then discarded, a significant portion of its value would be wasted. Repurposing the ship into a moon base allows NASA and SpaceX to preserve and reuse the technology already built into it. Converting it into a horizontal habitat optimizes every dollar, every hour, and every engineering advancement invested in its creation. Starship's true strength, however, lies in its long-term potential. Its large size makes it an ideal foundation for a base that can grow into a substantial lunar habitat. At first, the living area might be limited to the nose cone and payload sections. Even that alone would offer more room and improved facilities compared to many existing space stations. But once the crew settles in, they could begin to expand the usable volume by transforming the fuel tank sections. This would eventually create interior space measuring thousands of cubic meters, providing room for laboratories, workshops, storage areas, and living quarters for dozens of astronauts. This capability is one of the reasons SpaceX supporters defend Starship whenever it's compared with more traditional lunar landers. Smaller landers may help accelerate early mission schedules, but they remain limited to short-term goals and small cargo capacities. They can't compete with the scale and adaptability of a repurposed Starship when the time comes to build permanent infrastructure on the moon. To understand the urgency behind this strategy, it helps to look at China's plans. China currently aims to land humans on the moon around 2030. After making that first landing, they plan to spend the next 5 years building a permanent outpost. Their base, named the International Lunar Research Station, is being developed in partnership with Russia and already has a clear defined roadmap. China's recent missions show consistent progress, landing on the far side of the moon, retrieving samples, and advancing robotic exploration. If their timeline remains stable, they may achieve both their 2030 and 2035 goals. This is why NASA feels immense pressure. The US needs to land astronauts again and begin constructing a base before China completes its milestones. Even under optimistic projections, astronauts may not return until 2027, leaving roughly 3 years before China arrives. Building a base the traditional way would likely be too slow. It'd require numerous expensive launches, and the final result would likely be a small, limited outpost. By contrast, if NASA adopts the Starship approach, a large and capable base could be established almost immediately after the first landing. It offers speed, efficiency, and a level of long-term potential that traditional landers simply cannot match. SpaceX still faces a long list of challenges before it can take on such a critical role in humanity's return to the moon. The most urgent task is completing the final design of the Starship human landing system. This vehicle is drawn both excitement and criticism, and it remains the centerpiece of NASA's Artemis plans. SpaceX will likely need to unveil a full prototype in the first half of next year in order to keep the program on schedule. If the need of converting Starship into a lunar base is truly going to be implemented, SpaceX will also need to present a detailed conversion plan. This includes outlining how the vehicle will transition to a horizontal position, how its interior will be reshaped into a livable habitat, and what timeline is required to make the process safe and reliable. Before any of that can happen, the Starship system must demonstrate its fundamental capabilities. It still needs to reach orbit, deploy payloads, and land both stages safely. These basic milestones have not yet been completed, and they form the foundation of every future lunar mission. To reach the moon, Starship must be able to reach orbit efficiently. To land on the moon, it first needs to prove that it can land consistently on Earth. These essential achievements are expected to begin taking shape with the V3 flights next year. Once those steps are in motion, SpaceX must develop the in-orbit refilling system. This capability is vital for sending Starship to the moon because the vehicle requires multiple refilling flights to carry enough propellant for the journey. Refilling is also one of the most debated aspects of the program, yet SpaceX leaders remain confident. They often compare the challenge to the Dragon spacecraft docking with the ISS, a complex task the company has already mastered. All of this makes next year one of the most important in the history of Starship. It's a period where delays could jeopardize the entire schedule. The potential of Starship has been described in detail, but potential alone is not enough. SpaceX must overcome every challenge along the way, or the vision will remain only that, a vision. Humanity is surely approaching the moon with a mindset very different from the one that guided the missions of the past. This time, we are not simply visiting. We are preparing to build homes and transform the moon into a new world for future generations. Every major spacefaring nation understands this, which is why constructing a lunar base has become the true centerpiece of the modern moon race. In this race, SpaceX has captured global attention with its bold idea of transforming a giant transport vehicle into a fully functional moon base. This concept offers a powerful advantage in both speed and long-term growth, especially when competing against China's accelerating lunar program. Yet the road to turning this ambitious idea into reality is filled with obstacles. Even so, this is SpaceX, an organization that has repeatedly reshaped the aerospace industry over the past 2 decades. If they can solve the challenges ahead, the moon base will be only the beginning. Many more possibilities will open once humanity is established on the lunar surface. But that will be a story for another episode. Until then, stay tuned. Again, the former NASA chief is criticizing the structure of the Artemis program, arguing that Starship should be removed from the architecture and replaced with a dual SLS approach. Many are now questioning whether this proposal is meant to be taken seriously. Meanwhile, NASA has announced another delay affecting the Orion Artemis II rehearsal, and SpaceX has reached a major launch milestone in its history. The moon has become one of the most debated subjects in the space industry today, especially as NASA prepares to transition to a new administrator. Much of the current controversy centers on differing views about the direction of the Artemis program and what architecture the US should rely on as it attempts to return humans to the lunar surface. Among the most outspoken voices are former NASA leaders who repeatedly challenge the existing structure of Artemis. They warn that without significant changes, the US risks falling behind China in crewed lunar missions and long-term exploration capabilities. At the center of this criticism stands former NASA Administrator Mike Griffin, who continues to express strong doubts about SpaceX's Starship HLS, or Human Landing System for short. Although he rarely mentions the vehicle directly, his arguments often point toward the complexity of the orbital refueling system that Starship requires. He highlights the fact that the mission depends on multiple refueling flights, precise docking operations, and an unprecedented scale of propellant transfer in orbit. In his view, this degree of complexity creates too many points of failure. He argues that the concept is very unlikely to succeed, and in some statements, he has gone as far as to say that it simply cannot work. While Griffin is skeptical of the current American approach, he and several other former officials speak with admiration about China's progress. They point out that China is following an architectural model similar to the Apollo program, which has already proven capable of placing humans on the lunar surface. They argue that this this straightforward architecture is more reliable than the ambitious multi-step design chosen for Artemis. Based on this, Griffin concludes that the current plan should be abandoned starting with Artemis II. Instead, he proposes returning to an approach he supported nearly 20 years ago, a dual SLS system in which one Space Launch System rocket would carry the lander and the other would carry the crewed spacecraft. The two vehicles would then meet in lunar orbit, the crew would transfer to the lander, descend to the surface, complete the mission, return to orbit, and finally reunite with the spacecraft for the journey home. In this scenario, the architecture would rely entirely on NASA-controlled systems. The lander would almost certainly be similar to the Apollo lunar module built by whichever contractor NASA selected for the job. On paper, this approach sounds simple and traditional. However, when we look deeper at the costs and schedule implications, major issues immediately appear. And before we explore those challenges, it's important to remember why the original architecture that Griffin supported was eventually abandoned. The reason was not technical feasibility. The reason was cost. It was far too expensive to sustain. Even one SLS rocket has required enormous financial resources. Just developing the vehicle for Artemis I took over a decade and consumed tens of billions of dollars. When we imagine doubling that requirement, the expenses grow to staggering levels. Two SLS rockets would require their own lengthy production timelines each, with dedicated hardware and extensive testing. In addition, both rockets would need separate mobile launchers. Building one mobile launcher is already extremely costly. Building another only increases the financial burden. The lander presents another challenge. Blue Origin currently plans to launch its Blue Moon lander on the company's New Glenn rocket. However, in Griffin's proposed architecture, New Glenn is removed from the equation entirely because everything must launch on SLS. That raises a major question. Is Blue Moon even compatible with the SLS? If it's not, NASA would need to pay for a redesigned lander or an entirely new lander program. Either path would add significant delays and costs. Developing a lunar lander from scratch is not cheap. History has already shown this through the Apollo-era program, which took years of engineering and enormous funding to complete. Even after all of the hardware is built, the mission costs themselves would be extremely high. Launching a single SLS and Orion capsule for Artemis I cost roughly $4 billion for NASA. With two SLS rockets and a new lander added to every mission, the expenses would more than double. Eventually, the price of sustaining such a program would become too burdensome for NASA's budget, especially as Congress reviews spending priorities each year. Beyond cost, the timeline presents another major obstacle. We are approaching 2026 and Artemis III is currently scheduled for 2027. Rebuilding the entire lunar architecture at this stage would guarantee additional delays. It's difficult to imagine how NASA could construct two operational SLS rockets, two mobile launchers, a new lunar spacecraft, and a lander within the remaining timeframe. The answer is almost certainly that they can't. As a result, shifting to Griffin's plan would not only increase the cost of Artemis, but would also push the return of American astronauts to the moon further into the future. When we compare Griffin's criticisms with the realities of his proposed alternative, it becomes clear that the issues he raises are overshadowed by even greater problems in his solution. Yes, the current Artemis architecture is ambitious. Yes, it challenges the boundaries of engineering with orbital refueling and reusable systems. But attempting to replace everything now would cause even more disruption, more delays, and more financial strain. Continuing to develop the existing systems appears to be the most reasonable path forward. Starship, despite its challenges, remains central to this long-term lunar strategy. I agree that SpaceX often appears focused on Starship's broader potential, sometimes at the expense of clarity regarding near-term lunar milestones. NASA should hold them to firm expectations. NASA should require transparent progress reports, and NASA should help accelerate development by improving the efficiency of licensing and approval processes. But even with these concerns, the long-term importance of Starship is difficult to deny. If the United States aims not only to land on the moon before China, but also to maintain a sustainable presence afterward, then a vehicle like Starship is essential. Its enormous cargo capacity, large internal volume, and ability to transport large crews offer capabilities that traditional landers simply cannot match. Starship could deliver habitats, rovers, scientific equipment, and even full-scale infrastructure to the lunar surface. In time, its design could allow segments of the vehicle to become part of the base itself, reducing the time and materials needed to construct long-term settlements. Achieving these goals requires a robust orbital refueling capability. This is precisely the system that Griffin has criticized, yet many other leaders see it as the technology that will unlock the next era of deep space exploration. Among them is Jared Isaacman, the current nominee for NASA Administrator. He argues that dismissing orbital refueling is a mistake, and that both SpaceX and Blue Origin rely on it in their designs. He points out that the private sector is investing significant resources into the technology, reducing the burden on taxpayers, and when the system succeeds, it'll transform missions far beyond the moon. Isaacman raises a vital question. Are we trying to recreate what was done in 1969, or are we working to develop the technologies that will open the entire solar system to human exploration? If the goal is to compete with China in the decades ahead, a modern program cannot simply echo Apollo. It must use scalable systems, sustainable missions, and vehicles capable of supporting human life for long durations. The US now faces its most significant exploration challenge in more than half a century. The pressure comes from China's rapid progress toward its own crewed lunar landing, but it also comes from within as debates continue over cost, architecture, safety, and long-term strategy. Both immediate and long-term objectives are crucial. We must reach the moon before China, and we must build a program that can endure long after the first landing. SpaceX has dealt with skepticism from the beginning. Even now, many question whether Starship can fulfill its goals. This may be the moment for SpaceX to show steady, transparent, and consistent progress. If they do, they will remain the strongest choice for returning astronauts to the lunar surface. If you support ongoing Starship development and the vision of a sustainable future on the moon, leave a comment saying keep progressing. Don't forget to like the video and subscribe to follow every step of SpaceX's journey back to the lunar surface and beyond. It's becoming increasingly clear that relying solely on NASA's internal systems will make the return to the moon far more challenging. That point was reinforced once again when Orion, the spacecraft for Artemis II, encountered another setback. According to several reports, the 4 Artemis II astronauts were originally scheduled to conduct a launch day rehearsal inside Orion on the 19th. However, an unexpected issue forced NASA to delay the exercise. In an update last month, Mission Commander Reed Wiseman explained the situation.
It's been kind of an interesting week because we were supposed to be at Kennedy Space Center for countdown demonstration test, but we have delayed that test into December. It won't affect our launch schedule, which is fantastic. Charlie Blackwell-Thompson and her team at Kennedy are working hard getting this vehicle ready for us to go. But that kind of gave us a free week almost. So we spent the bulk of this week sitting down with our flight control experts and our teams here at Johnson, just working through all the questions that we've had leading up to today.
His comments made it clear that the team needed more time to evaluate concerns before moving forward with such a critical rehearsal. The delay appears to stem from a stain discovered on Orion's thermal barrier. NASA explained that before the planned countdown demonstration test, teams intended to conduct a day of launch closeout demonstration. That rehearsal was paused when a blemish on the crew module's thermal barrier prevented the hatch from closing. Repairs were completed on November 18th, and the closeout demonstration finished successfully on the 19th. NASA then chose to move forward with water servicing first and schedule the countdown demonstration test afterward, so that lessons from the closeout rehearsal could be incorporated. Although the statement outlined the issue, it did not clarify how the stain interfered with the rehearsal or provide a new date for the countdown demonstration test. Even so, NASA emphasized that the setback will not disrupt the overall mission timeline. Wiseman reassured the public by stating that the launch schedule remains unaffected. Still, the pattern of recurring technical problems is hard to overlook. Each delay highlights how delicate and demanding the Artemis infrastructure has become. Relying entirely on NASA's current hardware for future lunar missions appears less realistic with every new complication. For now, all eyes remain on NASA as it decides how to proceed. Now, let's return to SpaceX and its latest major milestone. SpaceX has successfully launched another Falcon 9 mission from SLC-4E in California, delivering 28 Starlink satellites into orbit. The payload was deployed exactly as planned, and the booster completed a clean landing on the drone ship, adding another smooth and predictable mission to the Falcon 9 record. At first glance, it may seem routine, but it carries meaningful weight. This launch marked the 156th Falcon 9 mission of the year, and the 573rd Falcon 9 flight overall. When combined with the 11 Falcon Heavy missions, 11 Starship flights, and 5 Falcon 1 launches, SpaceX has now passed the 600 launch milestone since its founding. Crossing 600 total missions is a remarkable achievement that highlights the company's unmatched pace and capability. Year after year, SpaceX expands its cadence, breaks its own records, and pushes the limits of modern spaceflight. With this momentum, future milestones, such as 600 Falcon 9 launches, or even 700 and 1,000 total missions, appear well within reach. And this is only the beginning. Once Starship reaches a higher operational cadence, it's expected to fly far more frequently than Falcon 9. If development continues as planned, Starship's flight rate could surpass today's numbers and propel SpaceX into a new era of capability. So far, SpaceX has completed 156 missions this year, leaving just 14 more to achieve its goal of 170 annual launches. With several weeks remaining and a steady manifest, the company is firmly on track. With this latest milestone behind them, the question becomes simple. What will SpaceX accomplish next? In any case, folks, this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.